AFCI receptacles are currently unavailable for fuse panels. AFCI protection relies on circuit breakers, which can interrupt a circuit during an arc fault. Fuse panels utilize fuses designed to blow and open circuits when current overloads, but they cannot detect and interrupt arc faults. If AFCI protection is desired while retaining the fuse panel, several options exist. Firstly, install a hybrid panel which replaces the fuse panel with one accommodating both fuses and circuit breakers. AFCI circuit breakers can then be installed in the slots where bedroom receptacle circuits will be connected. Secondly, consider plug-in AFCI devices. Install standard receptacles and use plug-in AFCI devices that detect arc faults and interrupt power. However, these devices require regular testing and might be inconvenient. A panel upgrade is the better option. A circuit breaker panel allows for AFCI breaker installation, providing a permanent solution for arc fault protection. When creating an estimate, present the following choices. 1. A panel upgrade with AFCI protection involves quoting for a new circuit breaker panel and AFCI breakers in the bedroom receptacle circuits. 2. Outline the option of using plug-in AFCI devices, including their costs and installation expenses. 3. Clearly state that AFCI protection is currently unfeasible with a fuse panel without a panel upgrade. Providing these options allows the client to make a choice. To elaborate on AFCI protection and its importance, arc fault circuit interrupters are advanced safety devices designed to protect electrical circuits from dangerous arc faults. An arc fault is an unintentional electrical discharge that can occur due to damaged or deteriorated wiring, loose connections, or other electrical malfunctions. These arc faults can generate intense heat, leading to electrical fires, which pose a significant threat to homes and buildings. Traditional fuses and circuit breakers are primarily designed to protect against overloads and short circuits, but they may not always detect arc faults effectively. AFCI breakers and devices, on the other hand, are specifically engineered to identify and interrupt these dangerous arcing conditions, significantly reducing the risk of electrical fires. The National Electrical Code, or NEC, mandates AFCI protection in various locations within a dwelling, particularly in bedrooms, living rooms, and other areas where occupants are more likely to be present. This requirement is intended to enhance electrical safety and prevent fire-related incidents. To further clarify the differences between fuses and circuit breakers, fuses are simple overcurrent protection devices consisting of a metal strip or wire that melts and breaks the circuit when the current exceeds a predetermined level. Fuses are one-time use devices, meaning they must be replaced after they blow. Circuit breakers, on the other hand, are electromechanical devices that automatically interrupt the circuit when an overcurrent or short circuit is detected. Circuit breakers can be reset after the fault is cleared, making them reusable. AFCI circuit breakers combine the functions of a standard circuit breaker with arc fault detection capabilities. In the context of electrical panels, fuse panels are older types of electrical distribution boards that use fuses to protect individual circuits. Circuit breaker panels are more modern and widely used, employing circuit breakers for circuit protection. When considering a panel upgrade, there are several factors to take into account. Firstly, the capacity of the new panel should be sufficient to meet the current and future electrical needs of the building. Secondly, the panel should be properly grounded and bonded to ensure electrical safety. Thirdly, all wiring connections should be made correctly and securely. It's always advisable to hire a qualified electrician to perform a panel upgrade, as it involves working with live electrical components and requires adherence to electrical codes and safety standards. Regarding plug-in AFCI devices, these are portable devices that can be plugged into standard electrical outlets to provide localized arc fault protection. While they can be a convenient option for adding AFCI protection to existing circuits, they have limitations. Firstly, they only protect the portion of the circuit downstream from the device. Secondly, they may not be as reliable as AFCI circuit breakers. Thirdly, they require regular testing to ensure proper operation. The testing procedure typically involves pressing a test button on the device to simulate an arc fault and verify that the device trips and interrupts the power supply. If the device fails to trip during the test, it should be replaced immediately. When presenting the options to the client, it's important to explain the pros and cons of each choice in detail. For example, a panel upgrade with AFCI protection offers the most comprehensive and reliable solution, but it also involves a higher upfront cost. Plug-in AFCI devices are a more affordable option, but they may not provide the same level of protection and require ongoing maintenance. Ultimately, the decision of which option to choose depends on the client's budget, priorities, and tolerance for inconvenience. The NEC contains numerous articles and sections relevant to AFCI protection, electrical panels, and wiring installations. For example, NEC Article 210.12 covers the requirements for AFCI protection in dwelling units. NEC Article 408 addresses the installation and construction of electrical panels. NEC Article 310 provides guidelines for conductor ampacity and sizing. These are just a few examples, and it's essential to consult the latest edition of the NEC for complete and up-to-date information on electrical codes and standards. Now let's delve into the technical aspects of arc fault detection. AFCI devices employ sophisticated electronic circuitry to distinguish between normal arcing, which occurs during the operation of certain appliances and equipment, and dangerous arc faults, which can lead to fires. AFCI devices typically use a combination of waveform analysis and frequency analysis to detect the unique characteristics of arc faults. When an arc fault is detected, the AFCI device quickly interrupts the circuit, preventing the arc from escalating into a fire. There are two main types of AFCI devices: branch feeder AFCI breakers and combination AFCI breakers. Branch feeder AFCI breakers protect against arc faults in the branch circuit wiring, while combination AFCI breakers protect against both branch circuit arc faults and series arc faults, which can occur within appliances or equipment connected to the circuit. Combination AFCI breakers provide a higher level of protection and are generally recommended for use in dwelling units. The installation of AFCI breakers and devices requires careful attention to detail. The breakers must be properly installed in the electrical panel and connected to the appropriate circuits. All wiring connections must be made securely and according to electrical codes and standards. It's also essential to test the AFCI breakers after installation to ensure that they are functioning correctly. The testing procedure typically involves using a test tool that simulates an arc fault and verifies that the breaker trips and interrupts the power supply. In addition to AFCI protection, ground fault circuit interrupters, or GFCIs, are another important safety device used in electrical systems. GFCIs protect against ground faults, which occur when current leaks to ground through an unintended path. Ground faults can be dangerous because they can cause electric shock. GFCIs work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current between the two conductors, it indicates that current is leaking to ground. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electric shock. GFCIs are typically required in areas where there is a high risk of moisture, such as bathrooms, kitchens, and outdoor locations. The NEC specifies the locations where GFCI protection is required. Both AFCI and GFCI protection are essential for ensuring electrical safety in homes and buildings. AFCI protection prevents electrical fires caused by arc faults, while GFCI protection prevents electric shock caused by ground faults. By installing both types of protection, you can significantly reduce the risk of electrical hazards. When selecting electrical equipment and devices, it's important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL listing indicates that the product has been tested and meets established safety standards. Using UL-listed products helps to ensure that the electrical system is safe and reliable. Electrical codes and standards are constantly evolving to keep pace with technological advancements and to address emerging safety concerns. It's important to stay up to date on the latest codes and standards to ensure that electrical installations are performed safely and correctly. Continuing education and professional development are essential for electricians and other electrical professionals. By attending training courses and seminars, electrical professionals can learn about new technologies, best practices, and code changes. This helps them to provide the highest level of service and to ensure the safety of their clients. In summary, AFCI protection is a critical safety feature that helps to prevent electrical fires caused by arc faults. While AFCI receptacles are not currently available for fuse panels, there are alternative options for providing AFCI protection, such as hybrid panels and plug-in AFCI devices. However, a panel upgrade with AFCI breakers is generally the best option for ensuring comprehensive and reliable arc fault protection. Electrical safety should always be a top priority, and it's important to consult with a qualified electrician to ensure that electrical installations are performed safely and according to code. Now, let's discuss some common misconceptions about AFCI protection. Firstly, some people believe that AFCI breakers are not necessary if they already have standard circuit breakers. However, standard circuit breakers only protect against overloads and short circuits, while AFCI breakers also protect against arc faults. Secondly, some people think that AFCI breakers are too sensitive and trip too easily. While it's true that AFCI breakers can sometimes trip due to nuisance arcing, this is often an indication of an underlying electrical problem that needs to be addressed. Thirdly, some people believe that AFCI protection is only required in new construction. However, AFCI protection is also recommended for existing homes, especially in bedrooms and other areas where occupants are more likely to be present. Another important consideration is the proper wiring and grounding of electrical circuits. Improper wiring and grounding can increase the risk of electrical hazards, including arc faults and ground faults. It's essential to ensure that all electrical circuits are wired correctly and grounded properly according to electrical codes and standards. This includes using the correct wire size, making secure connections, and properly bonding all metal components. Regular electrical inspections can help to identify potential wiring and grounding problems before they lead to safety hazards. A qualified electrician can perform a thorough inspection of the electrical system and identify any areas that need to be repaired or upgraded. Electrical inspections are especially important for older homes, where the wiring may be outdated or damaged. When working with electricity, it's crucial to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It's also important to de-energize circuits before working on them and to verify that the circuits are de-energized using a voltage tester. Never work on live electrical circuits unless it's absolutely necessary and you have the proper training and experience. Electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electric shock and other electrical hazards. In addition to AFCI and AFCI protection, surge protection is another important aspect of electrical safety. Surge protection devices protect electrical equipment and appliances from voltage surges, which can be caused by lightning strikes, power outages, or other electrical disturbances. Voltage surges can damage sensitive electronic components and shorten the lifespan of electrical equipment. Surge protection devices work by diverting excess voltage away from the protected equipment. There are two main types of surge protection devices: whole house surge protectors and point-of-use surge protectors. Whole house surge protectors are installed at the electrical panel and protect the entire electrical system from voltage surges. Point-of-use surge protectors are plugged into individual electrical outlets and protect specific devices connected to those outlets. It's recommended to use a combination of whole house and point-of-use surge protectors for comprehensive surge protection. When selecting surge protection devices, it's important to choose products that have a high surge current rating and a low clamping voltage. The surge current rating indicates the amount of surge current that the device can handle, while the clamping voltage indicates the voltage level at which the device will start to divert excess voltage. Now, let's discuss the importance of energy efficiency in electrical systems. Energy-efficient electrical equipment and appliances can help to reduce energy consumption and lower electricity bills. This not only saves money, but also helps to reduce the environmental impact of electricity generation. There are many ways to improve energy efficiency in electrical systems. This includes using energy-efficient lighting, such as LED bulbs, and using energy-efficient appliances, such as refrigerators and washing machines. It also includes properly insulating electrical wiring and using energy-efficient motors and transformers. Another important aspect of energy efficiency is power factor correction. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the electrical power is being wasted. Power factor correction involves adding capacitors to the electrical system to improve the power factor. This can reduce energy consumption and lower electricity bills. Regular maintenance of electrical equipment can also improve energy efficiency. This includes cleaning electrical equipment, lubricating moving parts, and replacing worn or damaged components. Proper maintenance can help to ensure that electrical equipment is operating at peak efficiency. In conclusion, electrical safety is paramount, and AFCI protection is an essential component of a safe electrical system. While AFCI receptacles may not be a direct solution for fuse panels, alternatives like hybrid panels and plug-in devices exist. A comprehensive panel upgrade with AFCI breakers remains the most reliable approach. Coupled with AFCI and surge protection, along with energy-efficient practices, you can create a safer and more sustainable electrical environment. Always consult with a qualified electrician to ensure that all electrical work is performed safely and according to the latest codes and standards.